everyone, welcome. Today we're going to go into our third day of applications of quadratics. First, we'll go ahead and take a look at this example. The area of the triangular sail shown in the picture below is 28. I'm going to go ahead and make a note of that, the area being 28 square feet. And also, I'm going to make a note that the area of a triangle is 1/2 the base times the height. We are asked to find the base and the height of the sail. Well, looking at our diagram, the base is 4x and the height is 3x plus 1. So what I'm going to do is simply plug all of that information into the formula that relates it all, where area equals 1/2 base times height. So if area is 28, I have 28 for A equals 1/2 times the base, which is 4x, times the height of my rectangle, which is 3x plus 1. Everything in this equation is in terms of x, so I'm simply going to solve to find the x. Once I find x, I'll plug it back in to find the base and the height. Simplifying, 1/2 of 4 is 2x, so I have 28 equals 2x times 3x plus 1. And now I'll go ahead and distribute that 2x. So 28 equals 6x squared plus 2x. And I'm going to solve. But first, I see that everything is divisible by 2, so I'm going to go ahead and divide both sides of my equation by 2 to make my numbers a little bit easier to work with. So I end up with 14 equals 3x squared plus 1x, or just x. Now, since I cannot square root both sides since there is a linear term, I'm going to go ahead and subtract 14 from both sides, getting me a 0 on one side. So I end up with 0 equals 3x squared plus x minus 14. I'll check and see if we can factor this, and if not, then we're going to use the quadratic formula. So negative 14 times 3, when I multiply those two together, I do get a negative 42, and I need to add to a positive 1. There are two numbers that work, and these are 7 and negative 6. So I have 0 equals 3x squared plus 7x minus 6x minus 14. I split down the middle and take out the GCF on the left. So I take out an x, leaving me with 3x plus 7. And on the right, I take out a negative 2, leaving me again with 3x plus 7. So my final factored form is 0 equals 3x plus 7 times x minus 2. So I set each of these factors equal to 0, obtaining 3x plus 7 equals 0, and x minus 2 equals 0. When you solve each of these, you will get x values of negative 7 over 3 and positive 2. Now going back to the question, we are asked to find the base and the height of the sail. The base is 4x, the height is 3x plus 1, so I'm going to go ahead and plug in my answers. The first is x is negative 7 over 3. Well, thinking about this, if I plug a negative into my base and I multiply by 4, that's going to give me a negative base, which we know we can't have. So I'm just going to go ahead and plug in my positive 2 for x. So base equals 4 times 2, which is 8, and our units are feet. And height is 3x plus 1, but x is 2. So 3 times 2, which is 6, plus 1 gives me a height of 7 feet. So our dimensions for this sail are a base of 8 feet and a height of 7 feet. Moving on. A cat jumps off a 3-foot-high kitchen counter at an initial upward velocity of 2 feet per second. The cat's height in feet is modeled by the function that follows. V is the initial upward velocity, and h, or h sub 0, is the initial height. How many seconds will it take for the cat to hit the floor? So this how many seconds tells us that we're finding t. So if this is my equation, I have h of t equals negative 16 t squared plus vt plus h sub 0. I know that v is the initial upward velocity, and looking back in our word problem, it tells us that the initial upward velocity is 2 feet per second. So that's going to be plugged in right there for v. Also, it tells us that the cat jumps off a 3-foot high kitchen counter. So that's our initial height. So I'm going to go ahead and plug these in. H of t equals negative 16 t squared plus my initial velocity is 2t plus h, which is my initial height, and that's 3. So now we want to know how many seconds will it take for the cat to hit the floor. So I want to know time when the cat's on the floor, which means the cat has a height of 0. So I'm going to go ahead and replace this h. This whole left-hand side of your equation represents height, so I'm going to put that equal to 0 and figure out how much time is it going to take for this cat to land on the ground. First thing we'll do is see if we can factor this. So setting up my diamond, negative 16 times 3 is a negative 48. And on the bottom I need a positive 2, and there are two numbers that work. That would be positive 8 and negative 6. So I'm going to split up my 2 with 8t minus 6t. I still have negative 16t in front and a positive 3 behind. Splitting down the middle, I take out a negative 8 from the left and also a t, leaving me with positive 2t minus 1. On the right, I can take out a negative 3, leaving me with a positive 2t and again a minus 1. Now I factor out that 2t minus 1, and I'm left with negative 8t minus 3. One thing I did not do that we should always do at the very first step is take out a GCF, even if that GCF is only a negative. Our leading coefficient can't be negative. So notice in this second set of parentheses there's a negative in front of the 8. I'm going to go ahead and factor that all the way out to the front. So I'm taking a negative out, that leaves me with a positive 8t plus 3, and then I still have a 2t plus minus 1 that I haven't touched. So this is our final factored form of our equation. Now we need to solve for t. So I take each factor, set them individually equal to 0. So 8t plus 3 is equal to 0, or 2t minus 1 is equal to 0. Solving on the left, I end up with t equals negative 3 over 8, and on the right when I solve, I find t equals positive 1 over 2. We're finding time, and both of these solutions represent time. The problem is that one of them is negative, that would be here on the left, while one is positive on the right. Since we're talking time, we are not allowed to have negative solutions, so it is going to take the cat 1/2 of a second to hit the floor. Next, a baseball player hits a ball. The height of the ball is modeled by the following equation, where h is the height of the ball, that should be b for ball, above the ground, and t is the time in seconds. If no one catches the ball, how long will it be in the air? So no one is catching the ball, meaning, if we think about that, it lands on the ground. So basically all we're doing is we're going to find out how long does it take for the ball to land on the ground. And that would be, where does the ball have a height of 0? So all I'm going to do is go up to my equation where h is, or height is, plug in a 0, and then solve for t. This is just another way to rephrase the question that we basically did on the last slide. How long does it take for it to hit the ground? So I set up my diamond. I have negative 5 and 2. I multiply those to go on top, and positive 13 on the bottom. There are no two numbers that will work for your diamond, so unfortunately we're not able to solve it with a diamond. So I'm going to go ahead and use my quadratic formula. negative b plus or minus b squared minus 4ac all over 2a. So t equals negative b, which is 13, plus or minus the square root of b squared, so that's 13 squared, minus 4 times a, which is negative 5, times c, which is positive 2, all over 2 times a, which is negative 5. So t equals negative 13 plus or minus the square root of 13 squared, which is 169. When I multiply negative 4 and negative 5, I get positive 20 times 2 is positive 40, all over a negative 10 on the bottom. So t equals negative 13 plus or minus the square root of 209 all over negative 10. Now, since we are talking time, I'm going to go ahead and approximate this solution. So what I'm going to do is on my calculator, punch in 209, take the square root of that, and I find it's about 14.5. So this gives me negative 13 plus or minus about 14.5 all over negative 10. I'm going to write my two equations. So negative 13 plus 14.5 all over negative 10, and negative 13 minus 14.5 all over 10. So negative 13 plus 14.5 gives me about 1.5 divided by negative 10, which is going to be about negative 0.15. To the right, when I add 14.5 with 13, I get 27.5, and that is negative. So I have negative 27.5 all over, this should be a negative 10. And that becomes approximately positive 2.75. So we have two answers. We have negative 0.15 and positive 2.75. Now we are talking time, so I'm not allowed to have a negative. So this first solution is not possible, which tells us that this second solution is our final answer. So it's going to take the ball about 2.75 seconds to land on the ground, or it will be in the air for approximately 2.75 seconds. The last slide that we're going to talk about has a couple parts. First, we have our equation where h of t is negative 16t squared plus h sub 0. This little h sub 0 just means the initial height. So going down to part A, we're told that whatever object they're dropping was dropped from an initial height, or h sub 0, of 8 feet. So I'm going to write my equation and plug in that initial height. From here, they want to know how long is it going to take for the object to hit the floor. So again, h is going to equal 0. I'll go ahead and let you solve this one on your own. Part B. This should say if the initial height was doubled, write and solve an equation to find the elapsed time until the object hits the floor. So now we have h sub 0 equaling 16. So my new equation is h of t equals negative 16t squared plus h sub 0, which is now 16. And we want to know when does the object hit the floor, which again means that it has a height of 0. So I put a 0 in for the total height and then solve for t. I'll let you go ahead and finish these two on your own, and then read through part C and do your best to answer and explain your answer after that. Okay, thanks so much for watching. I hope you guys have an awesome rest of your day.